With its seemingly infinite number of uses, paper is one of our most important and beneficial commodities. Most of us use it every day of our lives. But how many of us can say we understand the complex process by which paper is made? It begins here, in the world's forests, with one of nature's most amazing, abundant, and renewable resources, trees. From trees come the tiny cellulose fibers, which are the essential ingredient of paper. These fibers can be seen by tearing a scrap of paper and holding the torn edge up to the light. Along the edge, tiny strands of pulp fiber appear separately, like fine hairs. But the extraction of these fibers from wood and their eventual conversion into paper is a fascinating and complicated process. It is science. It is technology. It is the art of papermaking. Here at Appleton Coated, we practice that art with dedication, innovation, and an exceptional commitment to quality. On the shores of Wisconsin's Fox River, in the heart of paper country, the paper makers of Appleton Coated have produced quality paper since 1889. Today, Appleton Coated is recognized for producing high-value-added coated, fine, and specialty papers for global graphic arts markets. The world's most demanding printers, publishers, and designers specify our quality brands for their high-impact print communications, including annual reports, marketing brochures, publications, and innovative sales promotion. Our flagship brand, Utopia, is a unique, spirited line of coated free sheets. The line includes Utopia Premium, 1, 2, 3, and book grades. Utopia is available in gloss, dull, and matte finishes. Each day, our skilled people work with some of the industry's most advanced technology in this 52-acre complex. The first phase of producing paper is pulp making. Typically, both hardwood and softwood pulps are blended in the making of paper. Each has its own characteristics and desirable qualities. Softwood pulp comes from needle-bearing trees such as pine, spruce, fir, and balsam. These trees produce long fibers which give paper tensile strength to limit tearing and bursting. Hardwood pulp comes from leaf-bearing trees such as oak, ash, poplar, and birch. These trees produce short fibers. During the paper-forming process, gaps left by the longer softwood fibers are filled by the shorter hardwood fibers to produce a smoother, more printable, better-formed sheet of paper. The nearly 900 tons of pulp that are mixed and fed daily to the mill's paper machines come from two separate sources. A large percentage of the pulp required by the mill is high-quality kraft purchased from outside manufacturers. Appleton Coated also uses a portion of recycled pulp. The purchased kraft pulp is shipped into the mill's warehouse by rail in the form of bales. The bales weigh 500 pounds each, are sorted by type, and loaded by automated conveyors into pulpers. In these giant mixers, the dry pulp sheets are saturated with water. The pulp is converted into a liquid mixture of fiber and water. It is then pumped through refiners which brush and separate the fibers. The balance of Appleton Coated's pulp requirements is filled by its own chemomechanical process. Each year, the mill receives 30,000 cords of aspen logs, which are shipped from the forests and tree farms of northern Wisconsin. The 8-foot logs are cut into 3/4-inch chips. These chips are then fed into a continuous digester, where they are softened by heat and chemicals. The mixture is then bleached and sent through a series of refiners where the wood fibers are mechanically shredded into a fine pulp ready for use. All the pulp slurry is then stored in huge stock tanks or chests until it is pumped into a blend chest. Here, additives are blended with the pulp. This final mixture is then delivered to the machine chests, which feed each of the mill's paper machines. This part of the paper-making process, known as stock prep, features a state-of-the-art computerized system to monitor and control material flows to the paper machines. Stock preparation is complex, considering that each of our paper machines may be making a different grade of paper, each with its own recipe. When the final pulp mixture reaches the paper machine, it consists of 99.5% water and only 0.5% fiber. Pulp and paper making require vast quantities of water. Water is, in effect, the transportation system which carries the pulp through most of the paper making process. The mill's water filtration facility assures a constant supply, purifying up to 12 million gallons of water per day through its special sand filtration system. Paper is made on huge, complex, custom-designed machines which employ a series of different processes. The paper forming process begins at the head box of the paper machine. The pulp mixture flows from the machine chest into the head box, which spreads the water-laden mixture evenly across a continuously rotating screen called the wire. Gravity and vacuum draw much of the water through the screen, leaving a fiber mat. The water that is extracted, called white water, is reused. This portion of the machine is known as the fourdrinier. The wet fiber mat, traveling at speeds up to 3,500 feet per minute, is now 80% water when it reaches the press section at the end of the fourdrinier. Here, multiple presses exert high pressures to remove more water from the mat. As it enters the main dryers, the mat is 40% fiber. The paper grows stronger in the dryer section as moisture is rapidly evaporated by heat of over 250 degrees. The paper forming process you've just seen, from head box to dryer, from 99.5% water to 97% fiber, all takes place in but a few seconds. Leaving the dryer section, the paper passes through a coater. This part of the paper machine applies a thin layer of starch sizing or other coating on one or both sides of the paper. Appleton-coated scientists and engineers have developed innovative coating technologies for this complex part of the paper-making process. Next, these coatings need to be dried to remove excess water and create a thin film on the surface of the paper. After secondary drying, the sheet passes through a calendar stack to assure specified thickness and smoothness. Then, the paper is wound into jumbo rolls weighing up to 30 tons. From these huge rolls, the paper is rewound and cut into smaller, more manageable rolls. Once the rolls are removed from the machine, they are transported by a fully automated system to the wrapping and shipping departments, or to other areas of the plant for conversion into other finished coated-free sheet products. Appleton Coated's multi-million-dollar commitment to the production of the Utopia line of high-end coated-free sheet products features state-of-the-art coating and finishing technologies, both on-machine and off-machine processes, rewinding and calendaring capabilities, precision sheeters, and automated carton, skid, and roll packaging equipment. The facility also contains a graphic arts customer support center, unparalleled in the industry. The center features advanced press operations, complete with electronic pre-press technology and a 5-station Komori press dedicated to research and testing, ensuring the highest quality products for our customers. Creating superior customer satisfaction is at the core of Appleton Coated. So too is safeguarding the environment. Our operations have a long-standing commitment to voluntary compliance and environmental leadership. The mill's multi-million-dollar waste treatment facility and aggressive monitoring programs stand as testimony to this commitment. The art of papermaking as practiced at Appleton Coated is shaped by the values we share as a company. Customers, learning, integrity, people, risk-taking, improvement and performance, safety, and teamwork. Like the trees of the forest, these shared values are some of our most valuable resources. Their deep roots are a foundation on which the people of Appleton Coated will continue to produce world-class products and services for our customers.